Hello Vikings! Today we are going to talk about covalent bonds. We are still in Unit 4, our bonding unit. Our goal today is to learn how to name and write formulas with covalent bonds when we have two nonmetals bonding together. So that is our goal for the day. So we have looked at the different types of bonds that there are, and I'm going to bring back this slide that we looked at yesterday. We have ionic bonds. That's between a metal and nonmetal. So looking at the periodic table that I have on the slideshow, that would be combining the blue and the yellow. Next we have covalent bonds. If we have two or more elements that are yellow, nonmetals, on the right-hand side. The only exception to that is hydrogen. Remember that even though it's on the left-hand side of the periodic table, it is classified as a nonmetal. The third type of bond that we're going to learn in this class is metallic bonds, and this is when you just have a metal bonding with a metal. So everything involved is in the blue. So just a little review to get you back on track. We've talked about what a metallic bond is, as far as it being bonds between metals, but we really haven't discussed anything past that. Metallic bonds are a little bit different from ionic and covalent bonds. Metallic bonds, and the best way to explain it to you is to show you a picture, so I have one here. When you have metal atoms bonding together, they line up, the positive protons line up like soldiers, right? Because they don't attract each other because they're similar charges. Remember that opposites are going to attract. So they're going to push as far apart as they can from each other, and it's going to cause them to line up. But what happens with the electrons in a metallic bond that's different is, as you can see in the picture, they're kind of in all kinds of different places, and they're moving. They're shared between all the protons, all the atoms, and they call it a sea of electrons. So this unique property of metals bonding to metals is what makes the ability for us to form and mold metal. It's also what allows electricity to flow, because those electrons can flow so easily, and that's what current is. So remember the sea of electrons. There's not much more to metallic bonds, not that we're going to learn in this class anyway, but just remember that when the atoms bond, they just kind of have this soup of electrons or sea of electrons that they share amongst the atoms. All right, so we have already talked about ionic bonds, just refreshing you with the idea that these involve the transfer of electrons. When we look at metallic bonds, we just looked at they're sharing the electrons kind of in this sea. They're kind of, but when we look at the electrons in the ionic bond, we're having a transfer. So I'll show you the picture that we've used before. If we take sodium and its valence electron of 1, and chlorine has 7, chlorine wants 8 valence electrons, so it's going to snatch that one from sodium, and that's how they're going to bond. So it's actually taking it away. There's a transfer involved. Okay, so ionic bonds, just a reminder too, are between metals and non-metals. So now we're going to talk about covalent bonds, because this is the third and last type that we're going to learn about in this class. Covalent bonds involve a sharing of electrons, but it's not that same type of sharing that we looked at with the metallic bonds. Metallic bonds, they all share and the electrons kind of run all the way around. Covalent bonds, it's not that way. They are just shared in particular areas. And here's a good picture to show you what I mean. We have, there's an O, so we know that this is an oxygen atom. And oxygen is in group 16, I'm showing you here on the periodic table, which means 6 valence electrons. So there's your 6. So this is not a full Bohr model. This is just a Bohr model showing just the outer ring, because we know oxygen is on the second row, which means in reality, if we did a full Bohr model, we'd have that other ring there because there'd have to be 2 rings. So we're showing the valence, and the oxygen has 6, so it needs 2. So if it's bonding with hydrogen, it's going to bond with 1 here, and there's your pair. So now we have 2, 4, 6, and then bond with 1 here, and that makes your 8. So that's how water is formed, and we have H2O. So this is a covalent bond too, because unlike when we were doing the electron dot diagrams and you saw that arrow showing the transfer of electrons, you see how hydrogen and oxygen are sitting right there with their orbitals so that they can share that electron and both be full. Okay. All right, so again, covalent bonds form between nonmetals. So we are on the right-hand side of the chart, looking at only elements from the right, except for that exception, remember hydrogen. All right, so I have a cute video that kind of gives you a really, really good visual of the difference between an ionic and a covalent bond, and it's done by Dogs Teaching Chemistry. I love their stuff anyway, but I'm going to go out of this screen and pull it up this way, and I hope you enjoy this. Come on.
Welcome to Dogs Teaching Chemistry. Our first lesson is chemical bonding. Chemical bonds are what holds atoms together. A chemical bond is an attraction between atoms that allows the formation of a chemical substance. The electrons that participate in a chemical bond are called valence electrons. These are electrons that are found in an atom's outermost shell. Let's take a look at the types of chemical bonds that can be formed between atoms. An ionic bond is formed when one of the atoms will lose its electron to the other atom. This results in a positively charged ion, called a cation, and a negatively charged ion, called an anion. Positive and negative attract, and the result is an ionic bond. Covalent chemical bonds involve the sharing of a pair of valence electrons by 2 atoms. There is also what is called polar covalent bonds. These are covalent bonds in which the sharing of the electron pair is unequal. The result is a bond where the electron pair is displaced toward the more electronegative atom. Thanks for watching, and we'll see you guys next time.
So I love those dogs. They're so cute. All right. So as the dog showed, when you've got that transfer, one dog takes the chew toy, or it's representative of an electron, and takes it to himself. And then when we're looking at covalent bonds, the dogs are sharing. So it's a little bit different thing. Let's go to the next slide. All right, so just to find out if you know what kind of bond we're talking about, or you can pick out a bond type, we're going to go through some of these together. So remember, when we're looking for bond type, we're looking at this chart, okay? If I cross like one blue and one yellow, I'd be ionic, I cross. And if we see all yellow items, then we know we've got all nonmetals, and we're going to be covalent. So the first thing we have sodium chloride, NaCl, and we have sodium right here in group 1, blue. We have chlorine right here in group 17, yellow. So I cross. So this would be ionic bond. Okay. Then we look at the next one. This is water, and I'll teach you the correct name for water today. What you might call technical name. And so here we have hydrogen, it is yellow, and oxygen, it is also yellow. So we have 2 nonmetals, covalent bond. Then we have carbon. Carbon is yellow. We have chlorine. Chlorine is yellow. Again, covalent bonds. The next one, we have two elements, calcium and chlorine. Calcium is blue. Chlorine is yellow. So we have a metal and non-metal. So it's ionic, I-cross. And the last one we have carbon, hydrogen, and oxygen. So carbon's yellow, hydrogen's yellow, oxygen's yellow. So this one would be covalent. Okay, so that's how simple it is to determine what type of bond you have, but very important, because the first thing you have to do before you name something is determine what kind of bond, because we're going to find now that when we name covalent bonds that we use a whole different technique. If we were to name it like H2O, the technical name for it is dihydrogen monoxide, okay, because it's a covalent bond. And you'll learn the rules in a minute. But if we were to use ionic naming incorrectly, it would be hydrogen oxide, right? So there are different rules for ionic and covalent and how we name them. So just a refresher, when we do name ionic, we name the first item, and then we name the second item, changing the ending to "ide," sodium chloride. We have another one down here, calcium chloride. So how do you write formulas for covalent bonds? It's the simplest thing to learn. We just have to use prefixes to determine what subscripts we're going to use. We don't have to use any crisscross or any simplifying, nothing at all. So I am going to teach you what the prefixes are. And the good news, there are 10 to learn. And most of them you're probably already familiar with from other classes. 1, mono. 2, di. 3, tri. 4, tetra. And 5, penta, like pentagon. Okay. Then we have 6, and 6 is hexa. 7 is hepta. So if these are new prefixes for you and you're having difficulty trying to learn the two H, I call them the two H's, remember that hexa has an X in it and 6 does also. So that can help you determine which one's hexa and which one's hepta. And then 8, we've all heard of octopus, so octa. 9, nona, even if you haven't seen that before, very easy to remember. And 10, we have deca, like decade or decagon. All right, so these are the prefixes that you kind of have to get into your brain. And again, they're not too hard. Most of them you're probably already somewhat familiar with. So this is all we need to know to be able to name and write formulas. Okay, so the first thing we're going to do is try formulas. It says write the formula for sulfur pentoxide. So we see that we have sulfur, and if we look at the periodic table, we know that the symbol is S, and then pentoxide. Okay, let's look at our chart. Penta is 5. So we have 1 sulfur and 5 oxygen. Okay, so our formula would be, we write our S, and then we're going to have 5 oxygen. Okay, so 1 sulfur, 5 oxygen, just as it's written. So these are fairly easy. Write the formula for silicone tetrafluoride. So again, looking at our chart, we don't have a prefix, so we know there's 1 silicone. We have tetra, which is 4, so 4 fluorides. So silicon is Si, so we'd write our Si, there's one of those, and then we'd have to have 4 fluorines. Okay? All right, so these are easy. When we're writing the formulas for covalent bonds, all we do is pay attention to those prefixes, and they tell us what numbers to put. No crisscross, no nothing. All right, so how do you name? Okay, so naming's not too hard either. We use the prefixes. We name the first element, use a prefix. Name the second element, use a prefix. The only exception is that we never use the prefix mono for the first element. Okay, so always put a prefix unless it's on the first element and it's mono. Okay, and the other thing we've got to remember is we're going to change the second element to "-ide" ending. All right, so we're already somewhat familiar with this. So we're going to give it a shot. Let's see how we can do this. Name the following formula. P2O5. All right, so first thing I do is look at my prefixes. All right, we've got a 2, that's di. So our prefix would be di, and our element's phosphorus, diphosphorus. Then we have a 5, which is penta, and we could say pentaoxygen, but we know it's an ending element, so we have to change that ending to "-ide", so it would be pentoxide. So let's write that out, diphosphorus pentoxide. And when you start practicing these, some of these words are huge and they sound, you sound really smart when you're saying them, but it's not really that difficult once you break down how you do it. But you are going to make some errors in spelling just because the only way to learn how to spell these words and changes is through practice. Like, do you keep the A on pentaoxide or don't you keep the A? And I'm not worried about you getting those exactly right. What I'm worried about is that you know which prefix, and in this example with diphosphorus pentoxide, I'd be concerned about 2 things. That you have the correct prefixes, that you could tell what element it was, and that you changed the last one to "-ide". If you got a couple letters wrong, you know, you can learn along the way, but that's not the greatest concern. It's just understanding how they're named. All right, so then this is water, and if we look at it, we've got a 2, and remember 2 up here, we've got di, and we've got 1 oxygen, mono, so di and mono. So this one would be di, and name it hydrogen monoxide, dihydrogen monoxide. So now you know the official name for water. Okay, we will try one more. Name the following formula, CO. Okay, so looking at our little cheat sheet, we have 1 atom of carbon, 1 of oxygen. That means mono. Okay, but don't forget that we never apply mono to the first element. So in this case, we would name it carbon and then monoxide. And we're all familiar with this compound. We probably heard about this in the news or other science classes. Okay, so that's it for naming and formulas with covalent bonds. I hope you've enjoyed this video, and I hope everyone has a great day. Take care.